Let's go ahead and start talking about some properties of the graphs of quadratic functions. So we're going to be taking a look at functions in the form ax squared plus bx plus c, and in this case our a value is not going to be equal to 0. So let's talk about some of the properties that are going to come up as we look at these questions. The first thing we're going to talk about is the axis of symmetry. This is the line that's going to cut your parabola in half, and it has the equation x equals negative b over 2a. So let's go ahead and take a look at an example that we have here on the screen. We're going to be working with the quadratic function y equals x squared minus 2x minus 3, and we already have it graphed here, but let's go ahead and take a look at the axis of symmetry. We want to go ahead and identify the a, b, and c values off of our quadratic. So our a value here is a positive 1. That's the number in front of our x squared term. Our b value is a negative 2, and our c value is a negative 3. So let's go ahead and calculate the axis of symmetry. Our formula here is x equals negative b over 2a. We'll plug in the values that we have. Our b value is a negative 2, and our a value is a 1. This is going to give us 2 over 2, which is going to divide out to be 1. So the equation x equals 1 is our axis of symmetry. And we'll go ahead and draw this as a dashed line on our graph. Here's our x value of 1. Okay. And this line's going to cut our parabola in half. If we fold it over that line x equals 1, the left side's going to match the right side. Next formula we're going to take a look at is calculating the vertex. And our formula here for the vertex, let's take a look at a couple properties. Our x value is that negative b over 2a. And we already calculated this from our axis of symmetry, right? The one thing that we'll want to make note of is that the vertex lies on the axis of symmetry, or you can think of it as the axis of symmetry is always going to cut through the vertex of your parabola. Our y value for that vertex, we're going to have to go back to our function, and we're going to go ahead and plug in whatever that x value was, so that negative b over 2a value that we were looking at. Right, so the point that we already started to work with here, we have an x value of 1, right? That was that negative b over 2a. And we need the y value for our vertex. Now, obviously, we can take a look at the graph and pull that point off the graph. We know it's going to come out to be a y value of negative 4, but let's go ahead and take a look at how to calculate it if I only had an equation. Right, the function I'm working with is x squared minus 2x minus 3. And we want to go ahead and calculate f of 1. So we're going to plug in a 1 for each of these x values. And then we can go ahead and calculate this out. 1 squared is a 1. 2 times 1, we get a negative 2 here. And then we have minus 3 at the end. So 1 minus 2 is going to give us a negative 1. Minus 3, and our value here is going to come out to be negative 4. And that's what we were expecting. Right, so our vertex is the point 1, negative 4. You might also see this written as hk. H is nothing more than the x value off of your vertex. K would then be equivalent to the y value off your vertex. And let's take a look at a couple other properties here. If you're looking at your general form of your parabola, if your a value is something positive, so something bigger than 0, then your parabola is going to be opening upward. And if you take a look at our a value that we were working with, we had an a value of 1. Right, this is a number that is positive. So we expect our parabola to open up. And it does. We can see that on our graph. And anytime you have a graph that opens upward, right, you're going to have a minimum point to that parabola. And your minimum is going to occur at the vertex. If we happen to have an a value that is something less than 0, or in this case an a value that is negative, then we would have a parabola that would be opening downward. And in that case, our parabola would have some type of maximum value, and it would occur at the vertex.